Okay, so time for another video. This one's going to be on solving exponential equations with like bases. So we're going to use like bases to make this happen. So now we have to think of a basic rule. All right, here's the basic rule. If any exponential equation, right, any exponential expression, if the base of that exponential function has an exponent on it, okay, and then you're claiming that it is equal to an exponential function that is the same exact base, but it has a different exponential expression on it, okay, it must mean, okay, that the two exponential expressions must be equal, right? So if you're claiming that the first expressions are equal, then the exponents themselves must be equal, right? And I'll explain what that means in a second here, okay? So let's go through and do some examples, but that's your basic rule that you need to know. All right. Okay, so what we've got going on here is we've got this exponential expression, and the left-hand side says 10 raised to the quantity of 3x plus 5. All right, and the right-hand side says base 10 raised to the quantity of x minus 3. All right, so because the base is the same, all right, what we can do is we can logically say that 3x plus 5 must equal the same value that x minus 3 is in order for these two exponential expressions to be equal. All right, so from here it's just a matter of solving. So the whole problem states so long as the base is the same, all right, then their exponents must be equal. So here we go. So now we're just going to solve this linear equation. So first step, minus x. Oh, I don't know what's happened there, sorry. And then you get 2x, all right? And then this is minus 5, so 2x is equal to negative 8. And then going ahead and dividing by 2, and the answer is that x must be equivalent to negative 4. So if x is equal to negative 4, what you have is you'll have an equal expression. Okay? And that's it. That's all we're doing here. All right, so let's go on to another example. All right, so another example. So what makes this one a little bit more challenging? So notice that this is a base 2, and this is base 8. So I can't just be like, right, you can't go 6x plus 1, okay? 6x plus 1 does not equal x in this case, okay? So they're not equal to each other because their bases are different. So, but here's the thing about exponential functions, right? Exponential functions, all right, means that you could have a number that in of itself could be an exponential base, okay? So 8 is 8 an exponential base, meaning if you took 1 and raised it to the second, right, you get 1, right? But what if I did 1 to the third? Well, 1, you just get 1, right? So let's go to a different number. Well, if you have 2 squared, well, 2 squared is 4, right? But if you did 2 to the third power, well, what does 2 to the third power make? And 2 to the third power makes 8. So, and basically what I'm getting at is that the base itself is an exponential value. So what I can do is I can rewrite my base as its exponential form. So that means that the first side is still this 2 to the 6x plus 1 equals rewriting that 8 as its exponential of 2 to the third power. And now, right, so this is 8, so this is 8 raised to the power of x. So now what that inevitably creates, though, is this creates the power rule. And the power rule is when you have the power rule, you multiply your exponents. So I'm going to do 3 times x. So inevitably what I get here, so a little bit of work, is I get 2 raised to the 6x. The quantity of 6x plus 1 is now equal to 2 raised to the quantity of 3x. Okay? So now what happens is now all of a sudden, what I've got going on here is I've got that rule. My bases are the same. If my bases are the same, what must be true is their exponents must be equal. So 6x plus 1 must equal whatever 3x is if I'm going to claim that the exponentials are equal. So going ahead and solving this problem, I'm going to go ahead and subtract 6x, and I get 1 is equal to negative 3x. And at this point, I divide by negative 3, and I will get negative 1/3 will equal whatever x must be. So if x is equivalent to negative 1/3, then my exponential functions will be equal. So I hope that helps, all right? So there's an example of what if they're not the same. So let's go on to another one. So one more example here. So the next example we have is this. It says 9 raised to the quantity of x minus 4 and 27 raised to the quantity of x plus 5. Right, so if I take a look at this very quickly and you were to look at 9 and you were to say, hey, 9 squared is 81, well then you've already surpassed 27, right? So here's the issue with this one, right? So you're going to have to look at both of these, okay, as exponentials. So you're going to have to look at them as exponential expressions themselves. So how is it that you make 9? And as an exponential, the only way to make 9 is by doing 3 squared. So 3 squared makes 9. All right. And if I take a look at 27, how do I make 27 as an exponential? And the only way to make 27 as an exponential is 3 to the 3rd power equals 27. So again, what I'm just going to simply do here is I'm going to write their bases as their exponential form. So this becomes the quantity of 3 squared, so that's 9, right? Raised to the quantity of x minus 4. And then that equals, all right, 3, the quantity of 3 to the 3rd power, right, raised to the quantity of x plus 5. So it's raised to the quantity of x plus 5. So here we go. So moving forward. So now we have to do one simple step. So I'm going to write this as, so multiplying these out. So this becomes 3 raised to the 2 times x minus 4. If you want to actually distribute them, you can. You don't have to at this step. And this becomes 3 raised to the 3 times the quantity of x plus 5. So again, if you had wanted to distribute them, you could have made that 2x minus 8 and 3x plus 15 if you wanted to. All right. So now, look, I have my bases. They're the same, so what can be true is that my exponents must be equal. So 2 times x minus 4 must equal 3 times x plus 5. And then I go ahead and solve it. So again, this becomes 2x minus 8 equals 3x plus 15. And now it's just a matter of solving. So I'm going to do minus 2x minus 2x. I'm going to do minus 15 minus 15. And what I get here is that goes bye-bye, that goes bye-bye, and negative 8 minus 15 is negative 23 is equal to x. So if x is equal to negative 23, then my exponential equations would be equal. So my final answer is x must equal negative 23. So I hope that helps what you're doing. So if you're in my class, you're going to be mainly studying, not these examples, but you'll mainly be looking over examples 1 and 2 for your homework. But I did want to give another example like number 3. All right, so let me know thoughts, questions, and yeah. All right, thank you. Have a good one.